All right, can you hear me, guys? I think I'm supposed to wait a minute, but in lieu of waiting a minute, why don't I get you guys to listen to this instead? Here's some sound.
Feeling like you're living in the shadow of your former self? Don't have the cores to scale with your buddies? Frustrated with your lack of ability to scale that app, and your throughput is on its way down? You might not be getting slower. You might simply have a treatable condition called low scalability, or low S. If you're a developer or work in IT and aren't leveraging the Windows Azure Cloud Platform, you might be a victim of low S. So talk to Windows Azure about getting out from under the shadow of low S. The choice is yours. Start small, go big, develop, scale, connect. Unlock Microsoft's robust, feature-rich cloud platform. Move fast, iterate rapidly, be flexible, and minimize costs with the dynamically scalable Windows Azure environment. Potential side effects of achieving high S with Windows Azure may include raises, promotions, and bonuses you've always wanted. When leveraged regularly, Windows Azure can lead you to dev fame and IT stardom, including spikes in your Twitter following, guest blogging requests, and envy from other technology and engineering teams. Developers who get seasick or are allergic to grass should think hard before using Azure, as invitations to the corporate yacht and country club are likely when using Windows Azure. Hand cramping from signing autographs may occur on rare occasions, but is usually mild and will go away with regular coding. So get going with Windows Azure today. It's time to leave the world of low S behind, once and for all. Learn more at isitlows.com.
Yeah, I don't think that was PR approved.
Feeling like you're
like
living
that?
in the shadow of...
I hope nobody was offended. I just couldn't resist to make it worth your time for the delayed start. Well, welcome. My name's Scott Woodgate. Thanks for coming to this session. This is a 200-level foundation session. So the focus of this session is breadth of technologies, and I assure you we will cover a breadth of technologies. More than depth, which you'll find in the breakout sessions. We're also focused on the application platform, okay? So we'll have more of a coding developer focus in this session, although I'm actually going to start with a PowerShell demo, so go figure. So what I want to do is really make real some of the things that you heard Brad and Scott and Brian Harry talk through in the keynote. And frankly, I don't want to spend a whole lot of time on marketing slides because they did such a great job of that. You already heard what modern business applications is about. If I had to summarize it in my own words, it's pretty simple. You have to deliver things quicker. You want to take advantage of the innovations that are out there in cloud, on devices, in the back end. We can help you do that. It's kind of that simple. Where I do want to spend the majority of this session is actually building out from this slide, which really talks to how you would build applications in a modern business type of way. The first thing you see here is 6 building blocks for applications. And I could have been on stage here in the year 2000 and I would have told you the same 6 building blocks for applications in the enterprise context, right? Lots of the building blocks fundamentally in architecture level have stayed the same. Presentation, business logic, right? You're going to have to connect to the network across multiple systems, integrating things together, data, identity, they're all the same. What's interesting is, over the course of the last 10 years, if I use that as a point in time, the innovations that have happened in each of those areas. So presentation is obviously a pretty obvious one, from the phone through the tablet through the PC. Various framework evolutions to enable that have happened. If I pick another random one, identity. You know, in the enterprise, you were authenticating against Active Directory only, maybe still are. Facebook, Google, Twitter are also highly appropriate identity providers as well as ourselves. So there's a ton of innovation in each of these buckets, which is frankly interesting, but not where I'm going to spend the majority of the time. Where I'm going to spend the majority of the time in this session is talking through where I would deploy this logical architecture. What physical architecture do I deploy to? And today, most of you are deploying on-premises applications, okay? On one server or multiple servers, you're building out architectures that take these logical units and put them on-premises. And that's one model. And then on the other hand is the cloud model, okay? And actually, you can do all the same things in the cloud. And so then the question becomes, should I use this one? Should I use that one? How does that work? And depending on the type of business you are, the answers can be somewhat straightforward. Like, I'll give you a classic one. For a startup business starting today, where you have not a whole lot of capital, need to do something very quickly, the cloud is kind of a no-brainer. Because what's more, in 9 months' time, when you are successful with your business model, you need to scale and not re-architect, and you can do that with the cloud. Okay, so the cloud's kind of a no-brainer. For enterprises, that isn't necessarily the case. So how do I think about one versus the other? I don't think it is a one versus the other conversation. It's actually a both conversation. And there's some technology enablement, and then there's also some prescriptive guidance that I want to take you through to work you into that. So just to give you an example of a both scenario that's obvious, today you have gone through on-premises, many of you anyway, the migration into virtual machines on servers, where your workloads are running on virtual machines on servers. Those exact same virtual machines on servers, with absolutely no changes, run just great in the public cloud. And so you have portability in the application architecture between on-premises and in the public cloud. And now you need to choose, well, when would I use one in the public cloud and when would I use one on-premises? Okay? Development and test, which is an example that Scott Guthrie gave. In fact, it was the example that Scott Guthrie gave. I'm building an application that's going to run on-premises, but I'm going to take advantage of the cloud because, I don't know about you guys, but when I was working as a system integrator, I never had enough money to buy the right test hardware. So I'm going to use the cloud for that and go deploy in production on premises. It's a great use case example. There are plenty of others. But the scenario that I'm going to spend the most of this discussion on is, in fact, taking the best of both worlds. How can you understand why you would use the cloud and what you would use it for, and frankly, how you would use it? And then what would you use on-premises for? And let's do a single integrated scenario that takes an on-premises to a cloud, puts them together to a customer-facing solution. Okay? That's what I'm going to be focusing on today, the best of both worlds scenario. And in terms of some of the decision points you might go through in making that decision, I have a few of them listed down below. One of them is reach. From a reach perspective, obviously, there's a variety of customers here. Some customers will have multiple data centers. Many of you have one or maybe two. So if you want to do something that has global reach, the 12 data centers that are available with Windows Azure, including China that we just announced, is probably going to have more global reach than your existing data center. From an availability perspective, my app never goes down. The same is true in terms of the public cloud has that elastic scale aspect that your data center may not have. On the other side, from a data security or sovereignty perspective, there is likely information that you do not feel comfortable putting in the public cloud today. Okay, healthcare information, financial services information. You want to go and hold that information close to you in on-premises situations where you have all the dials, the control, the physical hard drive in your hand with the data on it. That tends to favor on-premises. While time to market, and I hope if you don't understand that time to market favors the cloud, you will understand it by the end of the session. It does favor the cloud. Clearly, your existing state is on-premises. And there aren't any real interesting applications, okay, promotional marketing sites maybe, but there aren't any real interesting applications that are in the enterprise that don't use information on existing systems, including sales information or CRM information. So you got to be able to access those, and not all of them, in fact, most of them are not moving to the cloud today. Manageability is an interesting one. Manageability actually needs to apply across both on-premises and in the cloud. And so that's one that isn't as much a differentiator as a business requirement to vendors like us to think about this joint scenario. So what I'm going to do today is build or tour a single integrated scenario that shows an example of an architecture that takes a best of both worlds approach. And this is a very similar scenario in a different context. Say hi to my son. As Bernd took you through in the keynote with EasyJet. Okay? So the scenario is set up here before I just show you the demo, and then we'll go show how we built it, is I'm a ticket vendor. Okay? And in this case, I'm selling tickets to events. And I've historically been selling business-to-consumer tickets for a good period of time. I have an existing infrastructure on premises. It's been working fine until, oh, by the way, anybody guess where I'm from? Anybody know? Yeah, close. The Giants, is that what I was supposed to? Yeah. No, I actually understand NFL. So from New Zealand. Hopefully you can catch up with the accent. So rugby's a big deal in New Zealand. And there's a really, really big rugby event that's coming. And lots of people want to come to it. All you guys need to learn rugby, right? We'll practice afterwards in the halls. And so what I need to do is move beyond my existing on-premises infrastructure that just can't scale for this particular event, and a couple of other hilarious ones, which you'll see in a minute. and create a scalable front end for it. Okay, so I have on-premises things that I want to keep in place, like my CRM system, and yet I can't scale to this new event that I need for rugby tickets to drive forward. By the way, that's a Fijian national player who's coaching my 4-year-old son, which is kind of funny, in Seattle playing rugby. Okay, so let's go ahead and show you the user experience, and I've deliberately kept this user experience simple. Oops, looks like I'm already logged in. The first thing I do is log into the website. Once I've logged into the website, which is my front end, one of my front ends, I can go ahead and choose my competition. I barely made it through Boy Scouts, but if international not tying's for you, you could choose that. Aaron Kelly, who you saw on stage, is really good at foosball. He was doing the sequel demo. But I'm going to go ahead and choose the rugby events. So as a user, I go in here, I choose my seating level. I can choose multiple levels in the stadium. Being a really big fan, I want to be right there. I want to be at the front row seat because, money isn't really the object. So I'm going to go ahead and choose my ticket and go check out. Okay. So fundamentally, a really simple scenario. And actually, we designed it that way so that I can take you through the architecture in the back end. I'm going to do that again, and I'm just picking up my phone because, as you'd expect, I want to have one of these user interfaces that's built off the phone. This happens to be a Windows phone. I can build this architecture out for Android and iOS, and I'll show you how later. But here I am. The one thing I want to point out here, if you see where my finger is that I'm recognized as a VIP. Okay? There's a certain class of customers that are anonymous people who come in from the web, and they're going to get a particular price point. And there's people like me who go to every single rugby game I can find anywhere in the planet, and I'm going to get a discount. And my discount is stored in the CRM system. That CRM system is on premises. Okay? So I go here and I'm going to buy, and I'm going through a user experience, or I'm going to do the same thing. I'm going to choose 40 to 50. I'm going to choose my seats. If you are noticing, the price point here at the moment is still $50. It's the same. But if you look on this screen, very, very quickly up the top, it did calling CRM system. And it provides me with a, right there, 25% discount on purchase. And I'll go ahead and purchase. Okay, so that's the user experience of this scenario. Pretty simple stuff, deliberately so I can show you a tour of the code in a relatively short period of time. Everybody with me? Anybody awake? Oh, there we go. Okay, cool. So now let me go back and quickly build out the architecture for you. So firstly, like many of you, I have an on-premises application. I have actually two of them in this scenario. One is the CRM application. It stores my customer information. It knows what customers are VIPs or not. It also has a whole bunch of private details of customers that I've chosen I don't want to make available in the cloud. So I don't want to take that information and make it available in the cloud, but I do want to be able to tell whether somebody's a VIP or not. It's my on-premises application. The second thing you see here is the infrastructure that we have in Windows Azure with the number 2 in the box. It's fundamentally a website that is fronting multiple Windows Azure SQL databases. That is the ordering experience. Okay? This is relatively similar to EasyJet, actually. And then the third thing I'm showing you here at a high level, is some more detail underneath this, is a mobile application. And my mobile application is actually using web APIs that are on front of my website on Windows Azure. Okay, so I have an on-premises thing, I have in the cloud thing, and I have multiple, obviously a web front end and a mobile front end. That's the architecture of the application. Everybody got that in their head? It's important to have this in your head because I'm about to go dive into the various pieces, and I don't want you to get lost on the way. The one thing I'm going to first talk about when I build is the website. But before I do that, I'm actually going to show you how to set up the infrastructure inside Windows Azure. So let's get out of PowerPoint. Everyone had enough of PowerPoint? And let's go straight into the Windows Azure portal. Briefly, for those of you who are new to Windows Azure, who's used Windows Azure before? Yeah, a few of you. The scenario I'm going to start with is I have my CRM application. Okay, it's running in Windows. I want a virtual machine to put it in. Okay. So I want to create a virtual machine in Windows Azure to put that CRM application in. So let me go ahead and create a new virtual machine. That CRM application just happens to use, let me see, choose one of these, happens to use SQL Server as a database. So I can actually create a virtual machine with Windows and SQL Server in it already in the cloud. I'll give it a name. Let's see if that one works. I can choose the size of the virtual machine. We support everything from really small to 56 gig memory for our virtual machines, so you can do some pretty good sized workloads here. I'll give it a login and a password. This is equivalent to what is the administrator's account. I'll go ahead and press next. I'll give it a public name, CRM SW1. We'll come back on the details of networking in a minute. It will be important. And create. And so what I've done here in the portal is kicked off a sysprec, basically, that will create a virtual machine image in the clouds that I can go ahead and use. And by default, when I kick off that image, I'll be able to, once it's completed, press this connect button to connect to it, because by default we'll expose a set of endpoints. Think about it as having a firewall around it, and we enable certain traffic through it to enable you to remote desktop into it. Okay? So by default, I press connect, I connect in. When I'm doing that by default, I'm actually connecting over the public internet into that virtual machine. I want to do something better than that in a minute, because my boss is a little paranoid about me using the public cloud. And actually, I don't want to deploy this dev test virtual machine with CRM on it ever in the public cloud. So I want to create a private network between me and Windows Azure, so no one else can get access to that at all. That has no public-facing surface. And we'll go do that in a minute. But before I do that, I want to show you something else. So this is the scenario where I've gone ahead and just created a virtual machine in the cloud. I already told you I had this running on a Windows server inside my business. So can't I just take the VM on my Windows server, upload it to the cloud, and create a virtual machine from that? Like, why do I need to start from scratch? Well, you don't need to start from scratch. And yes, you can absolutely upload that virtual machine in the cloud. Windows Azure stores all of our virtual machines, or your virtual machines, in Windows Azure Storage. And so if I browse here into Windows Azure Storage, the first thing I would do is upload the virtual machine I created on premise. Obviously, depending on your bandwidth, that could take some time. So here is a raw disk, well, it's not even that, it's a raw image file that is my VHD file that was running on Windows Server on premises. I just uploaded it into storage is all I've done. Okay? And so I'm starting from what I already have created. So once I've got this raw file, I can then go into the UI and create a disk from the raw file, where I would go in here and say my VM disk, browse back to that storage account that I was just showing you, and hook up the disk. And then once I've hooked up the disk, I'm going to actually stop here, I would then create a virtual machine. Okay? That's how you do it in the user experience. It works just great. On the other hand, if I'm using Windows Azure for development and test, I don't want to be clicking through the user experience every time. Because when I'm building dev test environments, I want to spin up infrastructure, and I want to spin it down. And I want to spin it up, and I want to spin it down. And I want to scale it out, and I want to scale it up, and I want to spin it up and spin it up. And it's not very time efficient to use the portal. So while it's going to be a little bit more complex to look at, what I want to show you is actually how to do anything, and I'll give you specific examples, in the Azure portal from PowerShell. So the thing that I'm going to do from PowerShell, just to summarize back, is I'm going to go into the storage account. I'm going to go get this file that I previously uploaded into the upload directory. I'm using this kind of like a library, so I'm going to first copy it to the VHDs directory, and then I'm going to create a running virtual machine from that. That's what I'm going to do. So if I open up my PowerShell prompt here, if I've never used PowerShell before with Windows Azure, there's one line I need to do to enable remote signing. The second thing I need to do, which is where we're going to start, is go ahead and get my Azure published settings file. Your Azure published settings file, and apparently I need to sign in, which is fine. Your Azure published settings file is the set of information about the account that enables PowerShell to access it. Think of it, it's got a bunch of certificate information in it, okay? And it enables PowerShell to set up objects inside your specific subscription. So I've got it, I saved it locally, then I use this command, which is import Azure publish settings file into the directory. It just happens to be in my default downloads directory. Latest version of that file is this one. Cool. And so what this is doing is now has the Azure commandlets in PowerShell are pointing to my subscription account. Okay, so it's ready to set up things for me. Now let's go look at the script. Just for your information, just to prove there's no magic, what I ran before you guys were here, because it takes a while to upload a VHD file, is this little add Azure VHD command that takes my local path, the VM on my local path, and goes ahead and puts it up into a storage account, which you just saw because it's in the uploads directory as winsql.vhd. Okay, that's what I've already run. Now what I want to do is run an additional set of script. I'm not going to go into the details of all of this, but the two most important segments I'll just highlight for you. The first thing I'm doing is copying from the uploads directory in storage to the VHD directory. Okay, that's basically what that does. The second thing I'm doing is creating a new virtual machine. And I'm not just creating a new virtual machine, I'm also putting it into a virtual network, which I'll explain to you in a more detailed way in a minute. So I go ahead and run the script. As I run this script, PowerShell is connecting up to my Windows Azure account. It's looking at that VHD image file. It's creating a disk from that VHD image file. It's then taking that disk once created, and it's putting it into a virtual machine. It takes that virtual machine once created, and it syspreps it, and off you go. That does take a little bit of time. It takes roughly 7 minutes to spin up a virtual machine. And so rather than have you guys wait while that does that, and by the way, this is the virtual machine I created before, still spinning up with the user experience. You'll see a second one come in later. I'm going to show you, there it is right now. That's the one I'm spinning up with PowerShell. Rather than waiting for this one to get going, I'm going to actually show you how to access a copy that I created using exactly the same technique. Okay? So this is Julia Child style. I've just already cooked it. And let's go ahead and attach to it. Now, what you'll notice here is this virtual machine has no connect button. It has no public endpoints, as I was saying before, because I want to be absolutely sure that I can tell my boss that there's no public internet access to this at all. None whatsoever. And so, how do I get access to it? Well, the way I get access to it is through a virtual private network. So, if I go over here and I click on this point to site and press connect, there's a piece of software that I previously downloaded from Windows Azure. I'll show you where in a minute. That is going to create a VPN between me and Windows Azure. Okay? In that VPN is a set of virtual machines. And so, if I connect to 10.0.1.4, it is going to connect directly from my machine through the VPN into Windows Azure. Okay? And so when it goes ahead and gets that done, then I am logged in to the virtual machine of my CRM system, which is my on-premises application that I am the only one that wants to dev test on-premises. And actually, you can see for the purpose of this demo, my CRM application is a really simple console stub, and you can see the calls that we made from the Windows Client app with 25% discount. Okay? So this is really, really secure. Only I have access to it. And now it's just a Windows box, right? I can do anything I want in terms of developing and testing within this Windows box. Maybe I didn't have a 56 gig dev test machine and I wanted to show a scale up scenario with SQL. Cool, I'll just create a VM in the cloud, put it up, off I go, run it, use it. And as Scott explained in the keynote, I run it for 5 minutes, put it down. We only charge you for those 5 minutes, so it's a whole lot cheaper than buying new expensive hardware. So here is my virtual machine of my on-premises stuff up in the cloud. Just to explain to you in a little bit more detail how I went ahead and got there. Let me just go back and show you networks. So what my PowerShell script did was create this network called point-to-site. The feature is, in fact, called point-to-site networking. And if I go look in the dashboard, sometimes that takes a while to update. It's going to eventually say it has one client. Then you can see that I have my virtual machine. This is the one I'm connecting to. This is the new one we just created while we were talking. It's in there. The way that I set up this network is I create a private key, public key pair on my local machine of certificates. I upload one of those. I download the software that I ran to connect to the VPN, and I'm up and going. Okay? And now I can say to my boss, yep, this is at 100% private virtual machine that only I can do development on. And frankly, in an enterprise context, I'd recommend this is the way that you use Windows Azure for your development machines. Okay, so with that in place, and having shown you how to connect to the virtual machine, one other thing I can just show you just for fun, because it's kind of cool, obvious but cool, is not only can I RDP into that machine, but there's the files on the file system, okay? It's just a file on my server network, just like any file on my server network. It just happens to be running in Windows Azure. Now I'm just using SMB file sharing. So I really have the flexibility to use this thing just like any other target I would have in the server environment. Pretty cool, huh? Okay, good. So I've got my virtual machine set up. Now let me go ahead and go back here, and I'll just quickly show you some, but not all of the other assets that I set up. So for example, let me go to websites. These are my websites that are running. We were using this one previously. Let me just show you how to create a website in Windows Azure. This is where, like, I'll challenge anybody in the room on websites or SQL databases or virtual machines in most cases on how quickly you can get it done. It literally takes 7 seconds to create a website on Windows Azure. It literally takes 15 seconds to create a SQL database. We typically poll the audience, how many people can get a SQL database in 15 seconds? Then you kind of go 15 minutes, 15 hours, 15 days. Depending on your enterprise, there's quite a few 15 days. The ability to get this done very fast when I'm in develop and test means that I can focus on writing code and not focus on waiting for hardware to turn up, not focus on procurement and those types of things to land. So this website that I just created is live on the internet, ready to go, just like that. Obviously, I need to put my code in it. While I'm here on websites, just for the people who are currently using Windows Azure, and I'll get into the right website, one of the things that we added to websites today, which is obvious but just didn't exist before, is the HTTPS support. So websites is not quite into production. It should come into production shortly. And HTTPS support is available as of today. So here you can see I've got my certificate from my CA added to my website ready to go. We also support domain names. So here's the domain names, Class C and Class C and Class A, but there's a domain name right there, as well as the default addresses. So if I step back and go back to my slides, what I've shown you briefly is taking a virtual machine with an on-premises application and moving that up into the cloud for development and test, doing it securely from a networking perspective. Creating a website. I did the same with some databases in the cloud. I just don't have time to show you that. Okay, I have those two things. Now let's get into Visual Studio. So I'm going to go into Visual Studio, and actually I'm going to go into Team Explorer rather than File New. And one of the things that I'm taking advantage of here is actually Team Foundation Service. Anybody using Team Foundation Service? Hands? Yep, yeah. I strongly recommend that people do. Even if you only use it for source code control, here is my source code. This is the first time I've ever used it on this particular machine. My source code's in the sky. I'm pulling it down from the Team Foundation service, and I am ready to go. And so, I lose my PC, all that good stuff, and I don't have the complexity of working with a server installation, which is the on-premises installation, which is even better. Okay, let's zoom this up a little bit, and let me show you what's going on here. So there's really two projects that I'm going to focus on today from a coding perspective. The first one is Buy Tickets. Buy Tickets is my ASP.NET MVC4 web application. Okay, that's the primary experience that you see when I'm navigating into the site and purchasing tickets. And then buytickets.phone is my phone application. Okay, everybody with me? So just one last time. I'm in here. I'm in this website application. So let me show you a little bit about that and talk a little bit about MVC. When you open up an MVC project for the first time, it can be a little intimidating because you can see a whole host of folders. MVC is Model View Control. It's a really great paradigm for creating web applications that are very easy to maintain. Let me explain what each of those components do, actually. So and by convention, these folders have specific names, which are important. So the models in an application, you can think of that as the data. So here is my seat model, and if I get out of zoom, you can see my seat model is in effect a class, and that class has within it a set of things that you'd expect to be using to describe data that's seats. It's got an event ID, it's got sections and levels and rows for the stadium makeup, it's got prices and the likes, okay? So models are classes that describe data. One really interesting thing here I'm doing, which is just super cool, is I'm actually using a feature called the entity framework. And the entity framework enables me to relatively seamlessly, sometimes very seamlessly actually, it's kind of scarily magic, serialize the data that I have in classes back into tables. And so I actually created the table that you see on the left and by the way, that table isn't running in SQL Windows Azure, not that you can tell as a developer. That's not running SQL locally, that's actually SQL Azure, but you can't tell, it looks all the same to you. I created that directly from this class. So that's the models. I similarly have a model for events. As an example, it's event name and locations and a variety of other models. So the models describe my data. The second aspect of any MVC application is my control flow for pages and also my shaping for data. And so I do that with my controller classes, once again, conventionally called controllers. And so if I look at this, I'll look quickly at the seats controller. The seats controller has a variety of methods in it. One of them is the event seats method. This pulls how many seats there are given some information such as levels. And the one I'm going to focus on today is the purchase. What happens when I purchase seats? Well, when I purchase seats, I relatively quickly go ahead and create a list of seats. I iterate through to find the currently I create a list of seats. I find the currently selected event. I iterate through the seats that are available for that currently selected event and add the ones that the user put a tick mark against because they're buying into that list. I go ahead and call out to my CRM system. What this is doing is checking if the current user is a VIP customer. And remember that CRM system's on-premise. It's not in Windows Azure, but I'm calling it. There's a little bit of work on cookies just to optimize performance, and I return a view. Okay? So inside the seat controller or controllers in general is the logic that shapes the data in the models and controls the flow for the pages, as is the case in this one. If I go beyond controllers, then there's views. And the views in MVC are all about showing you information. So if I go look at the purchase view, for example, and scroll down, you'll see I have a little bit of jQuery and actually no form validation at all in JavaScript, which we'd probably add later. And then I have the HTML for the page, as well as model code here, where I am iterating, for instance, because you're purchasing these seats, across the seats that the user selected. I'm going ahead and displaying what section they're in, what row they're in, what seat they were, and the base price. Okay? And I'm doing that similarly across. MVC is a very clean coding paradigm that also enables you to have great reuse. If I was starting a new web project for the framework today, I would absolutely be using the combination of ASP.NET MVC and actually the entity framework to simplify the data layer stuff. So that's a little bit on the user experience for the website. The second thing I want to show you is how we enable the phone to interact with the website. And the way we do that is through Web API. So if I go back into my project, and I zoom up again, I suppose, if I go into controllers, once again by convention, you'll see there's a Web API controller section. And this is a set of RESTful services that are available to call by any client, whether that be a Windows or a phone or any other type of device, that return JSON to the caller, okay, which is a text-based serialized object format. Okay, so if I go look into the seats controller in the Web API, first you'll see that it is deriving from the class API controller, which is what I need to do for Web API. And then you'll see a set of methods such as get seats or put seats. By convention, these methods have names get, put, and then obviously a set of parameters, and can be called from the website. There's some routing configuration, but basically I go website whack API whack seats, for example, and it'll return the results of some of these methods, or whack seats in a set of parameters in the query string, and it'll return some results. Okay? It's very, very easy to create these web API methods. If I contrast it in the WCF context, it's much, much easier to simply and easily expose information in web API. So actually what I want to do, just to add some code in here, is go ahead and add a new web API that enables me to do a summary of all the seats. How many of them in total have been sold? How many of them are remaining to be sold? So the first thing I'll do to enable that is to create a model, because I need to know how many are sold and how many are remaining. So I'll go in here and just create a class in my models section. I'm just saving some time because I'm going to be long on time anyway. There's my model code. It's just simply 2 integers. One is the total seats sold, the total seats remaining. I then go up to my web API, into the seats controller, in about here. And I'll add some code in the controller that plays with the model. And the code looks something like, oh, that's good. Let's not do the model. Let's do the code. Cool. It goes something like this. I want to create a method called getSeatSummary or seatSummary. And it actually iterates across 3 levels, 100 level, 200 level, 300 level, and collects all the seats that have been sold on each of those levels and returns that to the user. Cool. I've gone ahead and added that in. Now what I want to do is check it in. So I go in here and I check it in. Yep, those are the 2 files that I changed. I don't really want to build this on my local PC, and it's way more fun to show you anyway. Actually, what I'm doing now is checking it into Team Foundation service, and I'm taking advantage of the build functionality on Team Foundation service. Okay, so I'm sending this back to be checked into the source control. And actually on TFS right now, it's going to do a build. So do I have TFS open? Oh yeah, I do. It's probably one I did earlier. Okay, there you go. So I checked it in, went to TFS, told it go do a build. It's doing a build. It sometimes takes a while for TFS to do a build, depending on where it's at. The interesting thing about this is how does it get from TFS to Windows Azure? And the way it does that is you set up each of your websites, if you wish, so that they can take automated deployments. And so you literally connect TFS Online to Azure Online, and it all just magically works from there. And so once this refreshes, or not, you will see. Yeah, that's cute. Let me try that again. Dashboards, deployments. And what this is literally doing is showing you, in a minute, if it does it, showing you deployments that I've previously done in TFS on Windows Azure. And it does appear to be an issue here, so I'm going to come back a little bit later. But fundamentally, I set this up for automatic deployment so that when it is deployed in TFS, it automatically copies it onto my website and automatically makes it live. Okay? And you can actually see the history of the deployments here as you go do it. I might do one more attempt at a refresh, and then if not, we'll come back to a little bit later in the discussion. So this build service in TFS enables me to not worry about the computing on my PC and take advantage of the cloud for computing. And it looks like it's not getting there. Okay, cool. While I'm here, I want to go back to Visual Studio and show you one more thing. So you see that I have this iteration across the levels of the database. Why do I need to do that? Like, why don't I just put all the levels together? I'm actually taking advantage of a feature, I'm actually taking advantage of an architectural design pattern in Windows Azure called sharding. I don't have one database for all the seats. Okay? I want a scaled out data layer as well as a scaled out web layer. Okay? Web layer scaled out, data layer scaled out. The way I'm going to scale out my web layer, I'll show you later. The way I'm scaling out my data layer is I'm sharding. What that means is I'm splitting my seats into 3 sections. And so I have a whole database for the seats that are the 100 category, a whole database for the seats that are the 200 category, a whole database for the seats that are 300 category. That way, if I have a massive number of users coming to the system, I'm not getting into lot contention issues with a single SQL server. I have 3 of them going on. And so it really enables me to scale out in a very efficient manner. And you can see that in the AutoMagic that is Visual Studio. It automatically brought in the connection strings and the databases to my 3 different areas. The amount of work that I have to do in code to enable that actually isn't a whole lot. So if I go into my repository and I go look at my seat repository, I have a method here that takes the level that I'm interested in selecting tickets from, for instance 100, and selects the database connection string, and then passes that to the caller. So when I'm selecting seats by level, you can see it's making a call to that method. Is it level 100, 200, 300? Similarly, when I'm doing updates of seats by level, you get the idea. So I've literally got one method call here, and then in my web.config, if you're curious, I have 3 configuration strings to 3 SQL databases in the cloud, and it's iterating over that. So this is an example of a scale technique in Windows Azure that would be challenging beforehand. Before, you'd have to set up 3 SQL servers and get it all configured and da-da-da-da-da. And I can go do the equivalent to that in Windows Azure of creating 3 SQL servers in about 5 minutes. And then do this load balancing technique to enable my data layer to scale. Cool. All right, guys. Let's see how we're doing from time. So I thought you'd be pretty spaced out at this point with all the coding and zooming around. Hopefully everybody's caught up with me. One thing I want to do very quick, because I'm going to run out of time, is open these, take them with you if you want. One of you has, either you have or on a seat nearby, so if you don't have it, grab a couple seats nearby. One that has a little blue star with a black on it. If anybody's sitting near a seat or has a seat with a blue star with a black star on it, raise your hand. And if it's not on your seat, grab the ones next door, because there is one somewhere out there. If you do, you won that, and you're welcome to come pick it up at the end of the session. Anybody? Well, we got it. All right, congratulations. Amy, where are you? Amy, you're out here? Oh, there. At the end of the session, don't leave now. I'm not trying to scare you away. At the end of the session, Amy will be right back there to hook you up. Go to the Azure booth. We'll give a bunch away. I don't know how many more bikes, but a bunch more bikes away in the process too. Congrats. Okay, I want to move out of the code layer for a minute and talk at the prescriptive guidance layer. So topic change. In particular, how many people have built .NET Rich Client applications in this room? A few people? Okay, cool. This is for you. It also applies mostly to web-based design. In terms of modernizing those applications, this is some prescriptive guidance. The first of which is to use the MVC-like paradigms. Okay, in WPF, use MVVM. Okay, as an example, it enables that separation of code and state. It makes it a whole lot more portable. It enables you to put different user experiences on as well. It's a big deal. The second one is use portable .NET libraries. People using portable .NET libraries? Oh, it's a new feature in Visual Studio 2012. It subsets the .NET framework. You get to choose what versions it runs across phone, Xbox, and Windows. And so you create a library that's literally portable across multiple architectures, which saves you a whole lot of time as you're building applications that use multiple devices. It's a big deal. File new portable library, literally. Modernize your user experience. I must say, before I get to TechEd EMEA, we'll jazz up the user experience of our portal. There's certainly more that we could do to do that. That's a customer expectation. And I'd probably say the last one in aggregate, consider moving your business logic, if it is a more of a mono-tier application, either to the server or out to the cloud. And the best example I could give to that is actually this week or last week we announced Xbox One. It obviously has a pretty grunty CPU itself. It has 4 times as much power coming from the cloud. So when you can take advantage of the cloud plus the front-end client, you can get a lot more power. And actually, Xbox is using Windows Azure for some of the things they do, as you'd expect. So now let's transition to data, and I'm going to talk about that in 2 different contexts. The first is really giving you visibility to what you have available to you and when you should use which in the data layer. So SQL Server, of course, is the granddaddy of data, relational data, really strong BI capabilities. You saw some of the interesting new features there in terms of ease of use BI as well as the high availability stuff. It really is the complete database and will continue to be that way, whether it is in a virtual machine on Windows Azure or on premises, either physically or in a virtual machine. The Windows Azure PAS database, which I was using, why is it PAS? It's PAS because as an end user, there's no Windows there. There's no SQL Server management to do. There's no Windows management to do. It's just literally the table storage that you have to go do queries against. Is really helpful in building out scaled out web applications. The PAS database doesn't have the BI capabilities, as an example, that the on-premises database has. And also, by the way, if you're using SQL in Windows Azure, you're currently restricted, we keep increasing this, to 56 gigs of memory. So if you need SQL with more than 56 gigs of memory, you're going to want to do that on premises. Okay? The third one here is HD Insight. HD Insight's obviously the Apache Hadoop implementation. Enables you to do map and reduce patterns, takes a lot of compute. Best place to run that's in the cloud. It runs in Windows Azure. The fourth one is tables. Yes, we do NoSQL tables. So if you want to do a website that just needs a key value pair, it doesn't need atomic operations, then Windows Azure tables are actually very, very helpful for that aspect. And the final one is blobs. Blobs can be used in Windows Azure for storing videos. We actually store whole websites in blobs and then hydrate them internally. All those virtual machines that you saw in Azure Storage are effectively stored in blobs. Okay? So blobs are a great storage mechanism. So you really have a breadth of technologies to use in the case of data, depending on whether you're relational, structured, unstructured, in the cloud or on-premise. Speaking of in the cloud or on-premise, one question I get a lot is, I've got data on-premise, how do I get it in the cloud? Like, how do I make that work? And there's a number of ways of doing that. The first one's always on. Always on enables you to connect SQL in a VM or running physically, obviously, on premises to another copy running in a VM in the cloud. And then you can today do a manual failover between one and the other. Okay, so it's like a DR scenario. In the future, I won't tell you when, you'll be able to do an automated scenario, so it'll be more like high availability. The second scenario is SQL data sync. And actually, I could take you back there, but in the design of my architecture, I will take you back there apparently. In the design of my architecture, one of the things I wanted to do was to take a subset of the event information from here. Okay, all the events are in this database. Only the ones that need tremendous scale are over here. So how do I do that? How do I take the events database information from A to B? Well, I took advantage of the SQL data sync functionality that copies tables, effectively, or databases, up from my on-premises to Windows Azure. And so that's how it keeps it in sync. The next one's a backup functionality, where I can actually just back up my SQL database into an Azure blob in the cloud, so it's just there. And then finally, I think about this last one as a baby step into the cloud. If I'm not yet ready to move SQL into a virtual machine and put it on IaaS, but I do want the data and the logs to be somewhere else, then I can actually take advantage of the SQL engine on-premise, make no changes to any of my existing applications, not even connection strings, and redirect the data and the logs up into Windows Azure. Okay? So there is a wide variety of different ways, and there's more that's on this list actually, of taking data from SQL and making that available in the cloud, which is very, very helpful. Of course, when you do these things, you want to do it over virtual private networks, as I showed you from the demonstration that I did. The next area I want to talk about really briefly is integration. I showed you a web API, definitely the simplest way of creating a RESTful service. And while I showed you it, I guess I didn't ever show you it running. So let me just do that. Let's see, API seats. Just so you know, the web API, when it's run, looks like this. Okay? Here you can see the JSON that was returned from the check-in that I made, which was that total seats sold and the total seats remaining. Okay? It's just simple JSON. And while I'm here, if you want me to go back into code for a second, I can show you the Windows Phone application. So here I am in the Windows Phone application. And the Windows Phone application, let's choose, I don't know, let's choose seats. The Windows Phone application makes a call to pick up that JSON somewhere in here, right here. So if I look at the Windows Phone application, it's doing a different call here. It's calling the method that had a ton of parameters on it. So it's creating a URL string with the event ID, section, min price, etc. that came from the user experience. It's creating a web client. This is just the method that's used down here to deserialize the JSON return. And then it calls this web API, which is basically HTTP ticketed dot blah 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 whack API whack seats. That's all it's doing. So it's a simple web call. That's what drives the interaction from the user experience on my Windows Phone app. And as I said, easy to do the same thing using iOS or Android to attach to these web APIs. Okay, so web API, really easy way of creating a RESTful service cross-platform. Service Bus. Service Bus is a feature of Windows Azure I am also using in this demo. It serves two different purposes. The first purpose is for you to use it like MQ Series or MSMQ as a traditional queuing mechanism. When you're building loosely coupled applications, some layer in the architecture, maybe the web layer, hands off a message to a queue and returns to the caller, so it can scale a lot and it isn't blocked. Well, the next layer in the architecture, maybe some of the business logic picks it up and so on and so on. Okay? So it has the notion of queues where you put and receive messages on them across multiple tiers. That's the asynchronous model. The second model that Service Bus has, which is a synchronous model, I am using in this example, and that is for exposing data in my CRM system. Okay? I don't want to do a data sync and copy tables of all that customer information in the cloud. I've decided I'm risk averse. I don't want to do that. I do need to have a data contract between a certain amount of information in my CRM system, namely what's that person's email address and are they a VIP, transmitted from my on-premise system. And so I use the Service Bus Relay feature, which enables me to set up a WCF service actually over Windows Azure and connect on-premises my CRM service endpoint to Windows Azure. Okay? So by using Service Bus, I can get access to the specific data that I need inside the enterprise and not open up the whole database to everybody. And if you want to see that briefly, I could go into the code, although I'm a little bit out of time. If someone wants to see that later, that's fine. Let me just zoom up here and scroll down, and you'll see here I'm actually using this service bus right here, and I have a relay in place on that service bus, and then I've written some code to enable that. Okay, so that's the service bus infrastructure. EasyJet uses service bus, just as a matter of interest, in a very similar way in terms of connecting systems together. Hopefully Bert's okay with me saying that out loud. Okay, beyond that, we have workflow support inside Visual Studio. And actually today we announced BizTalk Services. BizTalk Services is integration in the cloud. So you have EAI as well as trading partner integration. EDI is available for you in preview today with BizTalk Services. And of course there's also a traditional on-premises BizTalk server. So I've got about 7 minutes left. Let me see if I can get through one demo that really brings it all together. So I've gone ahead and I've built this application, and I've connected on-premises to the cloud. But now what I really want to do is test the application. And so to do that, I'm going to go ahead and open up Visual Studio 2013 preview and take you through a cloud load test. Okay? So the cloud load test, and I guess you saw some of this in the keynote, is a new feature in Visual Studio 2013 in the extent that you can run the test in the cloud. Okay? Historically, when you were doing load testing, you'd be doing it firing off a bunch of threads from your local machine, shooting it up. Well, my local machine can't simulate the number of users that I want to show some real load on my website. It just doesn't have enough power, and I'll explain that in a minute. So I create a test here, I upload it to TFS Online. TFS Online then takes that test and fires it at Windows Azure, and that's how the load test works. So what is the specific test I'm doing? And this will take some time to run. The specific test I'm doing is hitting the home page, which is just what I show you, with IE9, using all the bandwidth I possibly can, and I'm going ahead in my run settings. Actually, I'll get it started just to get us going. I'm going ahead on my run settings and running with 4 agents, if you guys can see it there, and I will do 1,000 requests. So roughly, you can get 250 simultaneous users hitting the website per one core. Okay? I happen to have a dual-core laptop, so I could hit with 500 users. but I want to hit with 1,000 users. I can't do that. So instead of me doing it, I'm sending that test request up to TFS Online. It is waking up, which sometimes takes up to 8 minutes, but I know some friends on the team who've made it work a lot faster for me. But just so you know, sometimes takes up to 8 minutes to spin up that test, and then goes ahead and fires that test against the website, which happens to be Windows Azure. Now, I didn't check, and I probably should. Oh, actually, just one more thing, just so you know. There's roughly a 20-second latency between the test running and there you go, and a dot appearing. So what I didn't show you beforehand to set context is I have a single 1.75 gig website running here. So guess what happens when I throw load at it? It gets locked pretty quickly, and you can see my performance is terrible, and it's just going to continue to increase. So that's not going to work for me. What I need to do is increase the number of instances. The way that you scale Windows Azure websites is kind of scary. My 6-year-old daughter can do it. There I am scaling my Windows Azure websites. It went from 1 machine with 1 core to 6 machines. And by the way, if you wanted to go nuts, you could go to 4 core, 7 gigs of memory, 10 instances, which supports 90% of every running website on the internet today. And by the way, if you're in the 91 to 100 category, come talk to me because I'll change this later for you if you want to use it. Okay, cool. I've scaled it. Now, one thing I'll tell you, the TFS stuff is still in preview. You do not need to restart your website to enable Azure to scale. But for whatever reason, in this load test case, we're finding that it isn't picking up until that is the case. Okay. And then once we get done through that, you'll see this performance. Actually, I stand corrected. In this case, it worked perfectly. So you see the peak. I changed it to 6. It declined. And then off we go. Okay? And so that is the power of the cloud, ladies and gentlemen. I have a website on a front end to a back end system. I scale it. It scales massively. It scales both at the web tier and at the data tier. And yet, I'm using all the relevant information that is still in my application on premises. So I'm going to close. I recognized I covered a fair breadth of technology here, not a whole lot of depth. That's the design of these sessions. If I had 3 takeaways for you, the first one is play with these new technologies. It is really, really, really easy to pick up these new technologies and play with them. The cloud ones are like ridiculously easy to play with. MSDN people in the room, people with MSDN? Yeah, like press the activate button. We do require you today to enter in your credit card information. Don't freak out. We're just trying to keep the bad guys out. We're authenticating that you're a real human. We will not charge your credit card until you make, as a separate step, if you choose, a decision and change that in the portal. So yes, we require credit card entry. No, we will not charge you. We're just trying to authenticate that you're not fraudulent because we may have had some of that issue. But please do play with these new technologies. That's why you're here at TechEd, to learn these things. It's a lot of fun. The application that I just showed you took about a week and a half to build. So the stuff isn't really rocket science, and it's really fun to play with. From a production perspective, as it were, use development and test in Windows Azure. Even if you're building on-premises applications with that tremendously available test hardware just there and in the cloud, go ahead and do that. Use the VPN scenario. Tell your boss it's secure, it's reliable, I can do it. You will really get things done faster. And then consider opportunities within your businesses for when can I do a 2-world scenario? When can I take something I've got on premises, connect it with something in the cloud for a better business opportunity? Take that one back to your boss as well. So with that, I'd like to thank you for listening in. Wish you luck for the rest of TechEd, and have a great day. Cheers, guys.